a 1 hour session that we are planning every other Friday on topics related to AWS, cloud, digital, and related technologies. So today's topic is AWS Reinvent Recap. And because there is so much to cover, we are going to split that across multiple sessions, and you can pick and choose which of the topics appeal to you, and you can spend more time there, even when you are going through the recordings. And hello, everyone. This is Raghuveer, the speaker for today. And I am a manager with the AWS practice in Lighthouse. And I have been with KPMG for about a year now. And prior to that, I have spent around 17 years in the industry, working in various roles around project management and program management. And off late, for the last 5 to 6 years, I have been spending a lot of time in AWS cloud related migrations and evaluations in my previous role and in my current role in data and analytics solutions around AWS. So with that, let's get started. We will be focusing on serverless DevOps and developer tools related new features, announcements, and additional previews, etc. that were recently launched in the Invent 2022 or thereabout. That's what we will focus on, and we'll get started with the builder experience or the developer tools area. So the idea is not to go through a laundry list of everything that was announced, be it major or minor. So we have picked some highlights that we believe are either relevant or interesting enough to warrant your time. And even within that, we'll probably spend more time on a few of them and less time on others. Just to give you a jumping point for you to evaluate whether it is relevant to your interest areas or current role, and then do a deep dive or do a POC, etc. Or start thinking about those kind of additional functionalities or features that have been announced in any new solutioning or architectures that you build. So it's all about being aware of what's happening in this field. And even if you have attended reInvent virtually or in person, there was so much that was covered that it's possible that we have forgotten a lot of things that sounded interesting and we wanted to go back. So this is probably an opportunity for us to refresh our memory. So one of the big announcements this time in the developer tools area was the AWS Application Composer. This one is a service that was launched outside the AWS console as a separate package service. So if you look at, I'll show you my bad. This is very much within the AWS console. I got mixed up with a couple of other things that I wanted to talk about later in the slide deck. Sorry about that. So Application Composer, if you are familiar with CloudFormation and how it appears in the CloudFormation Designer, you may have seen a visualization of how your architecture or the stacks architecture looks like when it is visualized using the visual display that AWS CloudFormation Designer shows you. You can think of Application Composer as a similar way visually, but here is more functionality baked into the application instead of merely just visualizing what a CloudFormation stack does. So here is a tool that is a visual canvas for you, where you can have a list of different logical components which are AWS services available in a drag and drop interface, and you can place them on a canvas and connect them together and combine them, group them together, and go down to the level of detail required on each of those components to configure those components. And as you do that, you are actually literally building your application using those serverless components. And behind the scenes, the application is building the corresponding CloudFormation template for you and making all the configuration changes for you and the connections or references between these logical resources on the CloudFormation template, so that anytime you want, you can switch to the CloudFormation view and get a fully flushed out CloudFormation template based on the drag and drop interface, drag and drop exercise that you did on the front end. So we'll briefly look at how it looks on the front end, right? So this is the canvas on which you drag and drop the various components and building blocks of your application, primarily focused on serverless applications at this time, but eventually there may be some other capability for more traditional architectures as well as third-party integrations in the future. But like I said, As you can see on the left side, there are a lot of building blocks available, which are primarily skewed towards serverless service components. And if you want to look at a quick flow of activity that you would do on this interface, right? You would start by creating a project in AWS Application Composer, where there is an option to link that project with your local file system, which you see in the bottom of the screen. So if you choose to link it to a local file system, all the artifacts that are generated by this tool get cached or stored to your local drive on your local development environment. That way, if you already have an existing IDE like a Visual Studio Code or any other IDE environment setup, the code that you generate using this tool sits in your local environment, and you can use those tools as well to work on those generated code artifacts outside this application as well. So it's a two-way integration between the front end and the backend, so to speak, the code that is generated. So any change that you make on the visual interface gets reflected in the corresponding code on the backend. And similarly, if you manually edit an underlying CloudFormation template as that is part of this project in your file system, the next time you load it, or even while you're working on this application, the corresponding architecture changes and configuration changes automatically are refreshed and reflected on the front end screen. So you would typically drag and drop those blocks onto the canvas like you see on the screen, and then you connect these components using connectors. And those connectors give you 2 or 3 different capabilities, right? It could allow you to connect component A to component B and send an event across that connection. It could send data, or it could send credentials, or in the case of IAM, it can send a role. So those kind of connections are possible. So if you look at a detailed view of each component, you get options to choose the various configuration parameters for that particular component of your infrastructure, of your architecture. And then that way you compose an application that you have in mind using these building blocks and connections between them. So here is an example gift code redemption kind of architecture, where an API endpoint is exposed that receives that gift code. There is a small piece of Lambda that evaluates that code, and then it goes and updates the DynamoDB table about the usage of that code. And then for the actual redemption and a downstream commercial activity related to that gift code redemption, you can send it to a queue and then route it to a downstream Lambda-based function or a third-party API for that matter. So this is a small component, application layer component, which usually takes a lot of effort to build by hand, either using CloudFormation templates or CDK, etc. But here is a tool that makes life a little bit easier to get started without mastering the nitty-gritty of each and every component and its nuances as supported by CloudFormation. So once you have something like this built, this application will create the corresponding folder structure and the placeholder code components required, or folder structure required to hold the code and configuration for each of these components. And then like I said, you can also manually open those files and edit it in your favorite IDE also, and the same will get synced automatically to the application composer. So all in all, it's a fairly powerful and well thought out service, I would say. But currently there are a few limitations within which this functionality is released, right? This is in preview, and currently, there is no automatic deployment of the generated CloudFormation template to your AWS account. So it generates the AWS CloudFormation template for you, but then you will have to take the template and manually take it to the CloudFormation console and then run it or instantiate the stack. So that's one. I think that will eventually become an integrated functionality. And one more limitation I already talked about is that this focuses more on serverless architectures at this time. So that's probably going to be where a lot of action will be in the coming few iterations of this application. But yeah, we will have to wait and watch if they expand it to more generally available architectures across the board. So that's about Application Composer. This second big announcement in the developer space is a service called Amazon CodeCatalyst. This is the service that is launched outside the AWS console experience. The name itself, Amazon CodeCatalyst instead of AWS CodeCatalyst, is a hint, right? So this, as you can see in the next slide, this is how it is accessed at a dedicated URL, codecatalyst.aws. And you log into this application or service using a separate credential, not your IAM credentials or SSO credentials, but you create something called a AWS Builder ID, and you use that to log into this service. So what does this do? If you are familiar with the AWS developer tools ecosystem, right? You have various services like code commit, code build, code deploy, code pipeline, and the likes, right? Which allow you to do different activities or steps in a SDLC lifecycle, whether it is maintaining a source code repository or building or testing your code or deploying it, orchestrating pipelines, or even there is a cloud-based IDE called AWS Cloud9, which is a authoring environment where you can do your development completely using a virtual IDE. Even though all those services are in place, and even there is a service called AWS CodeStar, which gives you a few prepackaged patterns on how to create a software project and orchestrate it, right? All within the AWS environment and within the AWS console. But AWS is now looking at it more broadly and saying developers have these kind of needs across the board, irrespective of whether they are using AWS native services across the board or not. So you might be using GitHub for your source code repository, or you may be using a few other tools for your automated testing, building, deployment, etc. Or you may also be using some other tools in the ecosystem, like a Jira board for tracking your issues, or collaborating with your team, etc. So how do we make life easier for developers who work in these kind of standard environments, right? And how can we think about very standard application stacks like a React-based front-end application or an API development project, for example, or a serverless project based on API Gateway and Lambda, for example. So these are some standard patterns where I think today a lot of people spend a lot of time just setting up all these basic elements of a SDLC lifecycle. To make it easier, the Amazon CodeCatalyst service, what it does is gives you a set of blueprints for all these common patterns that I just talked about. And you can pick up one of those blueprints that meets your needs and instantiate that in your workspace or project. And that creates all these different components like a code repository based on your preference, right? Whether it is GitHub or code commit repository or a Jira workspace for maintaining an issue log or a backlog, etc. So all those different moving parts of how to run a project and how to create an automated build, test, development environment for the given technology stack is taken care of for the most part by the blueprint that you choose. And these blueprints are customizable too. If you have a very specific need to use a particular pattern, you can also customize those blueprints and create your own. This service is available in preview and is available for everyone right now. There is a free tier before any of these services get charged. So you can definitely create a builder ID, log in with that builder ID, and start exploring this service and see if it makes sense for some of the scenarios that we work in. A related service, I would say, is Amazon CodeWhisperer for developers. You may have heard about GitHub Copilot, which is a AI-assisted pair programming service. This is very similar. So there is a large machine learning model trained by AWS based on huge amounts of code repositories across various technology stacks, right? And based on what the model has seen in the past, it understands the structure of code, what are the general patterns in terms of how you structure your code or modularize your code in each of these languages. And based on a high-level outline or comments, etc., that you provide in your code, this service can actually suggest what should be the actual code that goes into a particular module, etc. So if you have not played with this service in the past, I would definitely encourage you to take a look at this. This is probably where a lot of things are headed in the future, right? AI assisted everything. So this would be a good way to get hands-on understanding of how this works. But again, I would caution you to do it responsibly as well. Don't put client confidential code without understanding the terms of use of this service, because everything that you put into your IDE after you enable this integration can technically be scanned by AWS and added to the repository for future training purposes. So be cognizant of that. So once again, this service is also not directly connected to your AWS account. You create an AWS Builder ID, and you can use that to authenticate yourself and use this service in your local environment, like VS Code or JetBrains IDE, or even in Cloud9. AWS Lambda also has an integration to use this service. You have to enable it from the Lambda console when you are modifying code directly there. This is actually not a new service announced in re:Invent 22. It has been around for a while, in preview for free for a while. What has been announced in re:Invent 2022 was basically a couple of enhancements in terms of additional languages supported. The way you access the service was not based on AWS Builder ID before, so that's new. And for large enterprises that want to enable the service for their IT teams and programmers, they can use AWS SSO, or AWS Identity Center, as it is called now, to enable enterprise level access to their all their authorized users. So those are some of the changes that have happened in the recent past. So this is definitely an interesting area you may want to take a look at. So that was a quick tour of what are the big changes in the developer space, and we now look at serverless, right? So Lambda is the biggest flagship product in the serverless landscape for AWS, and you may have heard in the past about Lambda cold starts. So that's a problem that has been there for a while, only semi-formally acknowledged by AWS. Part of it was the fear, uncertainty, and doubt that Amazon's competitors wanted to spread in terms of adopting Lambda at large scale, right? But there was the real problem underneath all that. Especially when it comes to Java-related execution environments, right? So to understand cold start, let's spend a minute on understanding how Lambda works in general. The re:Invent event featured a keynote address by Peter DeSantis, who is SVP at Amazon, and he spent a few minutes explaining how Lambda works under the hood, which was very good. So I captured a couple of screenshots from there to just give you a glimpse, right? So what you see on the right is a logical representation of a pool of compute environments that are set aside to run Lambda functions based on their invocation. So the way it works is you have a virtual machine environment on a host like T2 Micro, which is the environment where whenever a Lambda function is invoked, the Lambda function's code will be provisioned into that T2 Micro environment, and it will be run. And once you invoke a Lambda once, it will get provisioned and cached, and it will live there for a while. So if you immediately call the same Lambda function 3, 4, or 100 times, the initiation step or warming up the virtual machine environment and hydrating it with the code and settings necessary to run your code does not happen each and every time. That environment stays warm and lives there for a while and takes care of subsequent requests. So all your subsequent requests to invoke that Lambda happen very fast. That's called a warm start because the environment is warm. But the very first time you invoke a Lambda after a long gap, right? That's when there's no ready-made environment for the Lambda function to go and execute your code right away. So there is some, this is probably a better graphic to talk about that, right? So there is boot up of the virtual environment. There is some data transfer happening between the place where they store the code and then the virtual machine. And then there is a long cycle of initialization that happens before your Lambda handler is ready to run. So that initialization is typically the longest time-taking activity that happens whenever a cold start happens on the Lambda. And it's particularly stark when it comes to Java-based Lambda functions because of the way the JVM works. When it comes to highly scalable applications with millions of requests, even if very small percentage of your Lambda requests are hitting that cold start problem, that is still a good number of requests in absolute numbers, and some real user experience or a business critical functionality is being impacted by that cold start happening on a small fraction of your requests. So what they have come up with as a solution to this problem is to try and minimize the amount of time that is spent in doing all these initial steps before we get to the stage where we are ready to execute the Lambda code, even when it is a cold start, right? So here again, a different representation of the same thing with a little bit of more detail. So on the from left to right, we are looking at a time scale from the time Lambda is invoked. If there is no pre-warmed environment ready to execute that code, you start with creating that execution environment, you download code, and there is a runtime related startup or initiation that happens. And then there is initialization code inside your own Lambda function that is run before your Lambda handler portion runs, right? So all of that usually takes a long time. There is some amount of optimization that you can do in your own Lambda functions initialization code, which is the right half of this red box, right? Which you can optimize, but there is a lot of optimization that AWS can also do on their side, which is what this new solution is about. So what they have done in very simple terms is looking at this whole life cycle of initialization, they have picked a point along the way and said, here is where we will freeze this environment and take a snapshot. So instead of starting with a bare bones or blank virtual environment and initializing it from scratch every time a Lambda cold start happens, for every Lambda function, they run once you publish a new version of the Lambda function, they run the initialization step and take a snapshot of the virtual machine at that stage before the handler execution starts, and then store the snapshot or the image of that virtual machine in that state, right? So next time, whenever you are invoking Lambda function, they, instead of starting from scratch, they take that stored virtual machine image, which is a snapshot, and start it from there, and then run the handler function. So they're calling this SnapStart, just to evoke the meaning of having a quick start, as well as the fact that they're using a snapshot to make this quicker, right? So there are a few considerations when you adopt this approach. You get very good benefits in terms of reducing the cold start times. So even the small fraction of Java-based Lambda functions that are having very high latency, that is almost sped up by 10 times with this approach, right? And this is offered by Amazon at no cost to developers, so we can just start using it right away. We just need to make sure that we are publishing specific Lambda versions to take advantage of it. And any API calls that hit your Lambda, etc., need to specifically have ARNs with the Lambda's version number or an alias that points to a specific version number, in order to take advantage of the Lambda snapshot. There are a couple of considerations here. Maybe we may not have the time to go into a lot of depth here, but if your code is using database connections established during the initialization part of your code, obviously if you're snapshotting your image and then running it hours or days or weeks later, the database connection in memory will not be still alive. So you will have to account for that in your handler code and not assume that the initialization function has just run, right? Similarly, if you have access to any external data like AWS Secrets Manager secret in your initialization function here, and then stored it in memory and are planning to use it in your Lambda handler function, once again, there is a chance that the secret value may have changed or expired by the time the actual execution or invocation of your Lambda happens. So you need to account for that and maybe catch that error if you have stale credentials, right? And finally, in some specific use cases like cryptographic functions, there may be a need that every time you invoke this Lambda function, it needs to use a random number or a pseudo-random number generator to ensure that the cryptographic hash functions you are using in your Lambda function are always unique, right? You should not just run the same seed or same random number based code every time you invoke such a Lambda function. But if you are initializing the seed for that random number generation function in your init code, there is a chance that your cached image will execute with the same seed every time you invoke it. So you need to account for that as well. There are some built-in features in Lambda, sorry, AWS's distribution of Java, which will allow you to bypass that. So if you're working in this area, please look at the documentation for those details. All right, so that was Lambda snapshot. So yeah, this is once again a little bit more detail. Maybe we'll not go into that. There are a couple of hooks available on either side of the snapshot. So that you can actually write some custom code to handle the fact that there is a snapshot that is being taken, and then that snapshot is being resumed at a later point of time. So if your code needs to do something very unique just before a snapshot is taken or just after it is resumed, you can use this hook to add that additional piece of code. So that's what we are trying to illustrate here. So maybe we'll leave the amount of detail there and then move on to other areas, right? So in the EventBridge space, there is a new feature that is announced, which is generally available now. So if you look at the bottom right, I have put some color-coded highlights. There are some services or announcements which are just in preview, and some are in general availability, which means they are fully supported in whichever regions they are available in. So that means you can actually use it for production workloads. So EventBridge Pipes is one such service where instead of having us write a lot of glue code between glue as in not AWS glue, but general binding code between different AWS components to make those interfacing or integrations work between different AWS services. This service lets you actually pick a particular service and make the event flow all the way to the target service and do all the transformations or filtering or enrichment required in the middle without writing a lot of or virtually eliminating the need for writing any code in the middle. Some examples of places where you typically do a lot of custom coding, even though there are native integrations between AWS services, are let's say DynamoDB streams is being piped to an SQS queue, right? Then even though that's a common pattern, there is no code integration between these two services, and you will have to write code to make that integration happen. Similarly, Amazon Kinesis has a lot of different ways in which you can consume data of a stream and process it. And you'll probably use something like a KCL library, etc., to read data and then send it downstream. So you'll need to do a lot of coding there to process the data that is coming out of Kinesis streams. EventBridge is currently limited to around 6 source services, around 4 enrichment services, and around, I think, 14 destination services. But this is bound to increase in the future. But what you typically do here is in the Amazon EventBridge console, you see a new item on the left side menu called pipes, and you go there and click on create a pipe, and you get a canvas again, right? You broadly have this pattern of an event source, optional event filtering, an optional enrichment step, and a mandatory target step. So this is the broad 4-step process that it goes through. In the pipe settings, you can set up an IAM role to make sure that this service has the necessary IAM role to do the actions that it needs to do. And then in the event source, you select an AWS service that is supported. And then you have some settings like batch size and batch window. So you instead of parsing or processing each event at once, you can actually batch those events and process them. You have an optional filtering step so that in case you only want to process a subset of those events using this pipeline, you can do that using the filtering step. Similarly, there are optional services that you can use and plug in where you do additional enrichment, where you can do a transformation on that input event, add additional data or create a new event pattern out of it, and then send it downstream. And then finally, the step of target lets you select one of the 14 supported services and then send the event there. So this is a end-to-end integration of events instead of having to do one step at a time and then write a lot of integration code between those services. So this sounds fairly powerful. So depending on the use case, this may be a good option to pick up instead of writing and maintaining a lot of code. So take a look at your leisure and see if it makes sense to for some of the use cases that you are dealing with right now. All right. Another recently announced serverless feature is on the AWS step functions. So for those of you who are working with AWS step functions, you may have come across a particular feature called map. So that was a limited capability that was available within step functions, where you can apply one step or process sequence of steps of activities on an iterator, like a list of S3 bucket objects, etc. But they are calling it inline map now to distinguish it from the distributed map feature that they have just launched. So distributed map goes beyond that inline map feature in that it launches each of those child process in a separate process of its own, which allows you to scale that to a very large number, virtually unlimited number. So if you're doing something similar to a distributed data processing at large scale, but on a much higher abstract level. So here you're not dealing with a single record or whatever, but you're dealing with, let's say, one S3 object or a bunch of S3 objects at a time, and you are applying 2, 3, or 4 steps of processing on it or any other logical step using a step function. You can massively distribute that activity. You can go up to 10,000 executions in parallel using this feature. I mean, there could be use cases like while you are dealing with live data using a typical S3 step function setup today. You may also have bulk data processing use cases, for example, where you are dealing with millions of objects in an S3 bucket that you have to transform or convert, etc. And this is probably one way you can deal with the large scale of that problem instead of having to execute it in small batches and maybe run into days and weeks of processing time. This gives you that massive parallel capability. So you can consider this as an option if you have those kind of use cases. This maybe we'll skip over. Airflow is a service that lets you connect third-party sources of data across the large number of third-party services ecosystem. Amazon has recently announced a large number of additions to this space in terms of new services like Jira Cloud, etc. So again, if we are doing that kind of integration for any of our customer environments, this is probably a service that we should seriously consider. So with that, we will jump into DevOps now. Again, those were not the only changes or new features announced in serverless space, right? But those are some of the things that we picked for discussion. So there are multiple blogs, announcements, and reInvent talks, product documentation, all kinds of resources available. In any forum, if you need some guidance or where to start, etc., please feel free to reach out, and we can always connect you to the right sources. All right. In the DevOps space, we have a few new features. once again, I don't know how much of our immediate community works on hands-on DevOps related activities. So we may not do a lot of deep dive discussion here, but I'll give you a glimpse of what's coming here, right? So on the ECS service, there are already a lot of features like ECS service discovery that let you reduce the amount of very specific coding and coordination and orchestration required by you in terms of coordinating the communication between the various services that you define in your ECS cluster. The ECS Service Connect service that was just made generally available in re:Invent 2022 takes that to the next level of abstraction. So beyond mere service discovery by DNS names, you can actually do some telemetry on the traffic patterns between these services, etc. And between multiple ECS clusters also, you can make these services talk to each other and exchange information. So those kind of powerful functionalities are offered by ECS Service Connect. So if this is a space that you operate in, this may be an area of interest for you. Similarly, RDS now has fully managed blue-green deployments as a capability. So earlier, we were either doing in place upgrades or schema changes, etc., on a production cluster, which is okay for a small production environment which is not running a business critical application. But if you're dealing with large scale business critical databases, doing in place upgrades and schema changes is definitely not good idea. Because there's always a uncertainty in terms of how long that process might take, right? Especially when it comes to database upgrades, etc. So the other alternative was to do blue-green with a lot of manual orchestration and planning and cutover. So you basically plan for a green environment, replicate it, make sure that there are no replication errors, and then plan for a cutover and rollback if required. So what AWS has done now is make that blue-green deployments fully managed and available at a single click, or using a couple of CLI commands, like creating a blue-green deployment and then executing it, or canceling it. And AWS takes care of automatically creating a replica environment of your entire cluster, including any read replicas. Currently, it only supports one level of hierarchy. If your read replicas have another set of read replicas that are configured as the second level of hierarchy, that is currently not supported, but that should eventually come. But your green environment is automatically created by AWS on a single click. And then when you are ready, you can do a switchover like shown in the screenshot, right? You can either delete that blue-green deployment if you have changed your mind, or you can do a switchover, and AWS will take over the entire responsibility of migrating traffic and switching over from blue to green. And then you, by default, it will keep the blue environment intact. You are expected to manually review to make sure that the deployment has been successful, and there is no need to maintain the old environment before you get rid of it. So that's for highly mature DevOps based environments using Amazon RDS. Similarly, you have Elastic Disaster Recovery Service, and this is an existing service which has now got a feature upgrade in terms of automated failback. So if you're not familiar, you may have heard about Failover in the context of disaster recovery planning, right? So if your primary environment encounters a disaster, you have a failover environment where or a backup environment where you fail over all your traffic to, so that that takes over the load of your production workload, right? Now, that's usually not the end of the story. And eventually, when you figure out what's wrong with your primary environment and fix the issue, you want all your traffic and workloads to start running in your primary environment once again, and the backup goes back to being a backup, right? So that mechanism of redirecting traffic back to your primary environment after the disaster has been successfully mitigated is called failback. And typically in general setups of DR, the failback is not automated. But Elastic Disaster Recovery Service now has a failback mechanism where within AWS environment, if you have both your primary and backup environment set up, the failback of the failback from the backup environment to the primary environment can also be fully automated and configured. So a lot of that heavy lifting in terms of manually doing that and redirecting traffic is taken off, and the operations becomes a little bit more less human effort intensive. So that's what is the main feature there in the Elastic disaster recovery service. So similarly, there are a few new features in the AWS backup service as well. So most of them are in general availability. Some of them are in preview, like Amazon backup for Amazon S3. So yeah, if there is interest, maybe we can do a deep dive on these in a subsequent talk. Time check. We have around 15 minutes left in the hour, so I'll probably try and rush through the next few slides so that I do give you time to ask any questions or any other interaction that we want to enable instead of just being a monologue. So this CloudWatch Internet Monitor is a new service that is in preview, where AWS is saying that they have a large worldwide network presence using which they can monitor the availability of general public internet to various end customers, right? So across various countries and various geographies, they are able to detect if there are network latencies, outages, and other network issues that are impacting user experience in general. And they can pipe that information back to you as a architect or a operations guy to take that intelligence and use that to maybe either monitor your applications, the impact of your application and its users, or even take proactive action in terms of maybe failing over or rerouting traffic to a different from a different source, etc. Right? So that's what they're trying to offer here. So this is in preview. So hopefully, over few iterations, it will become more mature and integrated into your typical CloudWatch alarms and metrics, etc. That way, you can basically use your rest of your event-driven architectures to take actions based on any filtered alerts from this service as well. All right. Similarly, there is a feature where in CloudWatch logs, there is now a capability to automatically detect and mask any sensitive information that is accidentally logged, like your SSN numbers, credit card numbers, or other PII information. If any of, ideally, it should not be done. But at scale, it is not always possible to prevent poor practices when it comes to coding or logging, right? So even if by mistake a developer ends up logging some of the sensitive information into the application logs, which find their way into CloudWatch and get distributed to third-party systems, etc. This feature of logs data, CloudWatch logs data protection lets you automatically detect and mask that information before it gets widely distributed. All right. So there is a feature of S3 access points. S3 access points, if you're not familiar, are aliases for S3 buckets, which let you create multiple aliases for a given S3 bucket and then manage permissions on each of those access points separately from each other. So that if 3 different teams are using reading the data from the same bucket, you can grant them 3 very different set of permissions and direct them to different access points instead of managing all that complexity on a single S3 bucket with a very large and complex JSON document in the form of an S3 bucket policy. That's only one of the benefits, but they have further expanded that to make multi-region access points available. So a single access point can have multiple S3 buckets, one in each AWS region supporting it. So depending on the latency at that given point of time, any request that hits your S3 access point for a given object can be served by either a bucket in US East 1 or in Europe or in Asia, wherever the latency is less. And it is accelerated through the global accelerator that runs the AWS backbone. And those buckets across various regions are typically set up in a cross-region replication and configuration so that all objects are replicated across the board. But you have a lot of control in terms of whether you want to replicate everything in each bucket across every region or only a subset of them, or sometimes you may not even replicate everything from bucket A to bucket B, but maintain completely different sets of objects there depending on the usage patterns. But all of them can be clubbed under a single multi-region S3 access point so that you have a single S3 bucket compatible alias that your consuming process or users can hit. without worrying about where the bucket is or what each bucket's name is, right? So now there is a failover control available where you can set up some configuration rules to determine which bucket will take over or fail over to in the event of one particular region being unavailable for whatever reason, right? So that's a new feature that has been announced. Again, this is for highly, I would say, sophisticated environments where this level of performance tuning on a global scale is required. But it's good to have this as a solution should there be a need or a discussion around these kind of capabilities in any of your client environments. And finally, we have application recovery controller as a feature on Amazon Route 53, which gives you a lot of control in terms of how the disaster recovery and failover happens as you detect any health issues with a particular region or a particular availability zone. I believe regional failover was a feature earlier as well in the Route 53 application recovery controller. The zonal shift is a feature that has been recently announced. So within a AWS region, if there is some issue with one of the availability zones, you already had a few levers earlier, some architectural patterns using load balancers, etc. But now Route 53 can play a part in giving you that kind of resilience, so that at DNS level you can completely take one availability zone out of service if you detect any health issues with that availability zone. So typically in this pattern, you would disable cross-zone load balancing at the load balancer level and let the Route 53 ARC zonal shift functionality, which the load balancers also natively support, take over and completely take the affected availability zone out of service, so that you can you can build much more clear-cut resilience into your application instead of having what they call the gray failures, right? If you enable cross-zone load balancing, you may not even discover that there is an issue with an availability zone for a while. It could be a AWS service issue or an architectural issue in your application, which may be causing suboptimal performance in one availability zone. But because you have cross-zone load balancing enabled, you kind of tide over that without even realizing that there is an issue deep down that you need to address before it becomes a bigger issue, right? So having an alternate approach to this handling availability zone failures allows you to build that kind of basically force those gray failures to become hard failures, so that you can actually immediately cut over to a more reliable availability zone and then get into troubleshooting the problematic availability zone before too late. So that's the kind of functionality now available. So that brings us roughly to the end of the content that we have in store for today. We have around 10 minutes left. So if you have any questions or any inputs or contributions on these topics, please bring it up and we can discuss.